Hi everyone. Look, I just wanted to make a quick video on how to do electronic subshell configurations because this is quite difficult to explain if you can't actually see it. So have a read of the notes if you haven't seen this already. Have a look at what the subshells actually are. They're contained within electron shells. But in order to do a subshell configuration, to see what it looks like, you need to use a periodic table, or I think the best way to do it is to use a periodic table. And from this we can actually get a lot of information. So I've got a color-coded one here. Now the blue on this side, that is the S subshell. Okay, the orange is the P subshell, the red is the D subshell, and the green is the F subshell. So the way we do this is, well, actually, first of all, if we go down the side, the period numbers, 1, 2, 3, 4, and so on. So for now, we need to pretend that helium is over here. And so what this represents is hydrogen and helium are in the 1s subshell. Okay, so they're in period 1 in the S subshell. Okay, lithium and beryllium are in the 2s. Sodium and magnesium are in the 3s. If we go across, boron, carbon, nitrogen, they're in the 2p. Okay, so they're in the second period, but they're in the P subshell. Okay, so when we want to write a subshell configuration, what we need to do is look at the element that we want to write the configuration for, and we need to list the electrons that have filled up every subshell up to that point. Okay, so I'll give you an example. Let's look at sodium. Okay, so sodium's in there, difficult to see with the blue. So sodium is number 11. So we just need to list every electron that we go through to get to sodium. Okay, so if we have a look, we need to pass, we start at the 1s subshell, 1s, and there are 2 electrons in the 1s, or 2 elements you can see, hydrogen and helium. So we have 1s, 2. After the 1s, we go left to right, top to bottom. After 1s is 2s. Okay, so that's lithium and beryllium. And again, there are 2 of those. Okay, lithium is one, beryllium is the other. So those numbers, it's easier to look at those as, what those numbers are actually saying, the 2s2, that second 2 is just the number of electrons that are in that subshell, but you can look at it like you're looking at the elements in the periodic table. Okay, so lithium and beryllium, there's 2 of those in the 2s subshell, so it's 2s and then the little 2, okay, for 2 of those. Then we get to the 2p subshell, 2p, and we see there are 6 elements in there, boron, carbon, nitrogen, oxygen, fluorine, and neon. So we've got 2p, 6. And then we get to the 3s subshell, but you notice that sodium is the first in the 3s subshell. We don't need 3s2, we only need 3s1 because sodium is just the first one in there. If we were doing magnesium, we would have 3s2, but because sodium is the first, we just need that 3s1. Okay, so we only need to go as far as we need to get through. So if we go through, we have, hang on, I'll clear some space here. All right, so looking at sodium, we have 1s, 2, 2s2, 2p, 6, and then just the 3s1. Okay, and that's how we get our subshell configuration. Now, when you look at this, you can actually see some stuff that's pretty cool. The numbers in front of each letter tell you the shell that it's in. So the first shell here, the shell number 1, and this is the number of electrons in each. So our first shell has 2 electrons. Our second shell has, so both of those are 2s, it has 2 plus 6 electrons, so our second shell has 8. Our third shell just has 1 electron. Okay, and there we can see we've got the electron shell configuration of sodium. Okay, so what we have is up the top, that is our electron subshell configuration. Okay, this thing here is our subshell configuration. The one underneath it is our electron shell configuration. And that's how you write an electron subshell. So all you need to do is go through left to right, top to bottom, listing how many elements are in each section, okay, which are representing the number of electrons in that subshell, until you get to the one you want. Now the only trick with this is if we have a look at our D block actually goes back one number. So over here, potassium and calcium down here are our 4s subshell, but scandium, titanium, vanadium, chromium, they are all in 3D. So we go from 4s to 3D. Then if we go to the next row down, we've got 5s and then 4D. So the Ds just go back one step. Okay, that's the only trick. So let's do an example of this. Oh, I'll leave that there. Okay, so let's have a look at, let's do technetium down there. Okay, that's the one we're going to have a look at, technetium. And I'll get rid of the sodium just so we've got some room. Okay, now, by the way, the really good thing about this electron subshell configuration is you can do it for any element in the periodic table, whereas the electron shell configuration that you would have learned earlier, the 2882, that stops working after calcium. So I've deliberately chosen an element that comes, a long way after calcium so you can see how easy this is. So again, we just go left to right and write how many elements are in each. So in our 1s, hydrogen and helium, we have 2. In our 2s, lithium, beryllium, we have 2. We have 2p, and there are 6 elements in there. Next comes 3s. Oops, sorry about that. 3s, and there are 2 elements there. Okay, sodium, magnesium. Then 3p, starting with aluminium, going to argon, there's 6. Then 4s, there's 2 of those. That's potassium and calcium. Then remember, we go back a number for our Ds. Okay, so what we would have next, I'll move over a little, is 3D10. Okay, so we've got all that first row of Ds is the 3Ds. Then we go back to 4P, so gallium, germanium, arsenic, those are our 4P, 6. Then 5S, rubidium and strontium. 5S, there's 2 of those. And then in our 4D, we have 1, 2, 3, 4, and then the 5th one. Okay, so 4D, we'll have 4D5. Okay, now this is just about finished as an electron subshell configuration, but the thing is it looks a little bit messy. So what we would normally do is rearrange these so that the coefficients, the numbers in front, are in numerical order. So we're actually grouping these into shells. Okay, so our 4s subshell will move there, and our 3D will move there, and then our 5s will move to the end. Okay, so if we rewrite this properly, we get 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d5, 5s2. And so now we should be able to write our electron configuration for this. So in our first shell, in our shell number 1, we only have 2 electrons. So we've got 2. In our second shell, both of those are second shell, we have 2 and 6. We have 8 electrons. In our third shell, we have 3, 3, 3. There are our third shell ones. So we have 2, 6, and 10. So we have 18 in our third shell. In our fourth shell, we have 2, 6, and 5. So we have, 13 in our fourth shell, and we have 2 in our fifth shell. Okay? So that hopefully will help you create an electron subshell configuration. So you just need to break up your periodic table into those blocks, the S block, P block, D block, and F block. And then as you go through, just move left to right, top to bottom, and figure out, and just list how many are in each block for each row until you get to the element that you're after. Now, one more thing that you need to know about is if we wanted to do ions. Okay, so when our atoms lose or gain electrons, okay, how do we do that? Well, the thing to remember, and one of the reasons that we need to put our shells into order, is if we wanted to put, so we've got here, this is the technetium subshell configuration. If we wanted the subshell configuration for technetium 2+, so the ion, okay? You may remember, before I rearrange, well, actually, we can see up here, these were the last electrons we put in. But if we are going to 2+, we need to take off 2 electrons. We don't take off those 4d electrons, okay? Even though they were the last ones in, those are not the ones that disappear. The ones that disappear are the ones in the 5th shell, the ones that are furthest away from the nucleus. So to do Tc2+, we would just get rid of that. And that is the electron subshell configuration for Tc2+. Okay? Same thing if we wanted to do our electron configuration down here, Tc2+ would just look like that. Okay? So, that last shell is the one that loses its electrons when you form an ion, even if they weren't the last ones that you've put in. Okay, I hope that makes a little bit of sense. If you have any questions about this, please let me know. You do need to know how to do this, so if you're struggling, please email me. All right, thanks everyone.